Excellent. We're back. I want to bring your attention now to chapter two. Towards the end of chapter one, there's a talk about supervised and unsupervised learning. I'm going to elaborate on that in greater detail as we get more into the machine learning and AI part of it. Right now, what's written in there should suffice, but Lord knows I have stories to tell you on that front. Let me bring your attention to page 32, Exhibit 2 3. We're seeing a number of very interesting characteristics of big data: volume, variety, veracity, velocity, and value. Let me tell you a few stories about this. Regarding volume, so it says companies must now store petabytes of data. By golly. Let me take you back to February of 2011. That actually happens to be one of my earliest exposures to AI because the Jeopardy game with Watson on it, if you remember that, was what happened on that date. Uh, quick story on that. So the Jeopardy game, owned by Sony Corporation back then, Alex Trebek was around. God rest his soul. And we connected with him, and we said, "Look, we have this machine that I think can win the Jeopardy game against the masters of universe that you have." And I have to watch out with my hands on hitting the computer. And they said, "Okay, great, come on down." And we said, "Well, not so fast." The number of machines that it takes to run the Watson program at that point, imagine those sub-zero refrigerators, huge refrigerators, six of them, huge. Uh, Three of them were just they were really they were holding the data. It wasn't even a database really. It was a NoSQL database. We'll talk about that. Not it's not necessarily tables, columns, and rows. It has passages, words, text, paragraphs in it. It contained 5 petabytes of information. Wikipedia, New York Times, the CDC, The Economist, Al Jazeera, Der Spiegel, Le Monde. This thing was packed in. It's just packed with nonsense. And we had to train. I was in charge of helping train the system. One of the annotators I was working on was inverse document frequency annotator. We'll talk more about that as we get into the algorithms. And Sony Corporation, we said to Sony Corporation, look, we can get a C-17 cargo plane and put these things over there and bring it there, but we can't even be connected to the internet. This is a local that won't be fair to the humans. We convinced the Jeopardy folks to come up to T.J. Watson Research Laboratories at upstate New York. It's in Yorktown. Gorgeous, gorgeous building. It's a half a circle, designed by Frank Lloyd, and the stones used in building it were dug right from the quarry that surrounds the building. The quantum machines are on the second floor, and the Watson machine now in a museum on the first floor. People can come and visit. And the rest is history. Watson won that, but 5 petabytes, and this was all on RAM, not necessarily not in the storage, but in cached. So it had to retrieve it really quickly. And so yes, volume is getting, especially unstructured data. This is where unstructured data lives. Where do you think you'll find this in Microsoft SQL Server, IBM DB2? Is this in Oracle? Nice tables column? No, no, no. These are images. These are texts. They're not in tables, columns, and rows. Maybe no SQL, but nowadays, my dears, they are housed in vector databases. The entire database is designed for vector graphics. There are no tables and columns and rows there. The next one is variety. Um, Absolutely, absolutely. Already we mentioned there's 3 of them right now, dominant. Aside from structured data, CSV file, Excel spreadsheets, SQL call you might make from a database and get your records say saved as a CSV file. It's about tables, columns, and rows. Great, great. And then there's the unstructured data. Text. In the beginning, it was text. We started to work on images. And now it's videos. Notice all three of them comprise what we call multimodal learning. That's how we learn, us humans. There was an old fallacy that used to say, "Well, I learn best by videos. I don't read." Mm. Some of my students now, when I'm teaching in the other university, I have a book assigned for reading, and they hardly read it. I think it's changed, but they are learning. They are learning. This book, my dears, you must read. Why? Because the tests and exams are from these pages and these chapters. Furthermore, now videos are into play, and videos. That's right, not just images, videos, multimodal. So we learn, as humans, we learn by using all three of them. It's a fallacy for me to say I don't read or I don't watch anything. I like to do. I'm a very tactile, hands-on person. That's how I learn. Well, that might be very true, but we can't ignore the other two methods. We learn in a multimodal way, and so does our machine. Veracity. I'm seeing veracity down here. Yes, data could have missing values, inconsistencies. A big job of a data analyst is looking for the integrity of the data. And oftentimes you ask yourself the question, was the bias in the algorithm or was it in the data? The value. Value really applies to all of the above. You can say that the extracted data must be converted into quality insights. The notion of garbage in, garbage out is very much true. And this book mentions that. I want to bring your attention to the next page, page 34. And there's talk of SQL, invented by IBM. And then there's talk of NoSQL. That's right, NoSQL databases. That's the one that we were using with the Watson Jeopardy. Nowadays, OpenAI and the French company Mistral with their generative AI offerings. It's another ballgame. It's a totally different ballgame. They're using vector databases. Vectors. It's a direction. There's an arrow in here. It's a vector. Go that way. See my forehead? Gosh, it's getting bigger. This line used to be down here. I don't know what happened. So there's a vector that comes in. This vector, RGB colors. Remember RGB? I think white is 255 and black is 0. Black is lack of color, white is all of them, all the colors in spectrum put together. So if you put a vector, this is kind of darkish, maybe 240, and it gets lighter, it's a little bit lighter here, and gets dark, and the numbers are changing. So it's a vector. It tells the tale of if it wants to design this, from here there's this much clearness, and if you have more convolutional neural networks, greater clarity, you can probably see the lines building up over here, telltale sign of age. So the machine now gives a prediction, this guy has to be between this and that age. Really, really fascinating work that's coming out. Yes, page 36. ETL. But this is not a museum piece, ETL. It is used to this day. I don't care what sort of a data you're working with. 2026, we'll be still mentioning extract, transform, and load. That's really the beginning of what it is that we need to do to get into make sense, insights. When I think about this, the little box in here, Exhibit 28 on page 36, if you think about it, there are things that you know. Driving, cooking, being a brother, sister, mother, father. There are things that you know. Quite a few of them. If you take all the people in the world, I think we hit 8 billion, 8.1 billion. And all the things that they know will probably fit in that corner of my attic right there. See, where is it? It's right there. Imagine this is the universe. 13.8 billion light years big. Everything that we all know fits in that one corner of the universe. Well, there are things that you know that you don't know. So you cannot use a chatbot. At least you know what you don't know, so you can ask a question. A good chatbot will do that. That would probably fit in that corner of the universe. And the more we learn, this one section gets bigger, and maybe the ones that section gets smaller. Okay, okay. Well, what about the rest of this room? Those were just the two corners. The entirety of this room that I'm sitting in, this 3.8 billion light year universe. That's unknown unknowns. What it is that you don't know, that you don't know. I can't even ask a question. That's insight. That's where AI comes in. You know what AI is good at? Finding the needle in the haystack. Very, very fascinating. Stay with me, my dears. I'm taking you on. Ah, yes, this is a great point in here. I'm on page 41. And speaking of the quality of data, they have brought forth a number of bullet points in here that are really spot on. Timeliness, huge, huge. Zara, H&M, these are clothing stores. I like H&M, but I'm getting a little bit too old for their style, I think. They are embarked upon AI through social media, Instagram, Telegram, TikTok. They're noticing the fashion that Gen Alpha, Gen Alpha now. It's not just Gen Z. My boys are Gen Z. Gen Alpha is a little bit younger. And immediately they have to see what it is. The jeans have all of a sudden, they look like big tubes coming down. Well, they look pretty good, actually. And things have changed, the clothing and so forth. And so they need to be on top of it. These companies, if they want to sell their products, they can't be selling pants with pleats in them anymore. It's quite a thing. Oh, here's another one: completeness. Imagine if a company wanted to send an email follow up to their best customers, did not collect email addresses. Oh boy, got work to do there. Story for you. I am working now with a law tech. You've heard of ed tech, right? So this is law tech. It's a world of lawyers. Lawyers have this thing called the due diligence, which really takes a big chunk of their time. This thing called due diligence. Are all the papers signed? No. So we use AI. We upload these documents onto the machine. It's a generative AI machine. That means it is built on a large language models. That means if I say it understands my colloquial way of speaking, accents and all thrown in there. This machine doesn't come up and say, I'm sorry, would you repeat that? It knows that a wise man is not the same as a wise guy. One word changed, the entire sentiment changed. It knows that. But now I have uploaded my own PDFs, Word, and documents. There's a fancy name for it. It's called RAG, Retrievable Augmented Generation. More on that later. So this system goes inside and looks through all these pages and finds out the needle in the stack, the page 275 that is missing the signatures. It's quite a thing. And other components that would make the due diligence of law firms to cut down on the hours. I mean, just that is something that takes days. The machine can bring it down to. I spoke with the co-founder and the founder of this company I'm working with. I saw it with my own eyes. Went to the meeting with the lawyers. What would take days is done in 10 minutes. I don't know how happy lawyers would be for that, because now their hourly charge is diminished a bit. But now they can take more clients. Boom, boom, done with it, quick, and next. And it talks about consistency and the format of the data. Speaking of format of the data, I wanted to show you this book that I was talking about. This is, there we go. Yep. See it? Go. Prediction Machines. It's written by Masters of Universe. They're at the University of Toronto. This book has an economics flair to it, and it is mandatory reading for my in-person class that I teach here in Boston. I wrote this down in here, and I want you to actually write it down. It's economics is about balance, right? But where you gain something, you lose something. Fascinating. Every right hand must have a left hand. More data. Are you writing this? I'm watching you. More data, less privacy. More speed, less accuracy. More autonomy, less control. Fascinating, huh? How this works. The more autonomy you have on your agents, the less control we humans have on what can transpire. If you want speed, that's fine. I'll give it to you speed. It's going to cost you accuracy. You want a whole lot of data? Absolutely. You know how much more data there is in here you don't have? But guess what? It's a loss in privacy. Really, really fascinating. That's why I am really pumped about these initiatives. Europe has one, GDPR. There's the California Act. New Jersey has one too. It's designed for exactly that, to keep the privacy of our citizens intact. One other key point, my dears, about more data, big data. I want to remind you, not remind you, I want to bring to your attention David Kenny, mentor of mine. David Kenny, he was the founder and the CEO of the weather company. IBM bought the weather company, so he came into our fold. His head was just in the 22nd century, still is. And he was the one that really started to talk about, look, man, we gotta go API route. Selling products is not working anymore. And he was the one that said, and I won't forget this: the winner of the AI race is not the country with maximum information on their populace. Is not the university or college with the master algorithm, although typically it does come out of universities, these master algorithms. But it is the one entity, usually universities. It's funny how the transition goes from where the companies become the innovators and the universities are trying to catch up. Remember Bell Laboratories? That's one heck of an innovator. Where's Harvard in here? It's a to and from. Who comes up with the transformer technology that runs ChatGPT is from Google. LLMs, large language models, is from Stanford University. It's really fascinating how they come up. Foundational knowledge they come. So he came up with this. He said the winner of the AI race is not the entity or the group that has all this maximum data. It's the one that can do maximum AI with minimum data. Maximum AI with minimum data. That's me. I woke up this morning. No, I didn't find me a gun, but I woke up this morning and I saw a little light coming through the window curtains there, and could still feel the wind though. But I had this feeling it's going to be an awesome day, and it is. How much data is there? Good luck to the machine to make that prediction based on that feeling. I hadn't even gotten off the bed. Usually, I have my first glass of water, and then I get out and this. Not even that. Just open my eye, and I'm like, man, it's going to be a great day. So it's analog devices, right? Because word has it that by 2026 we are going to run out of largeness of large language models. Everything there is will already be accounted for. You want more data? You got to go to another planet, find another society, because we got this covered on Earth. So now what do we do? Well, I remember when I started with Watson a while back, we had visual recognition. In the beginning, I would give 50 pictures of mine, zip file, just a nice zip file, upload a zip file. The machine would build the patterns. And then I would send a 51st picture, unknown to the machine, maybe like kind of like this with the schnoz hanging over there, casting a big shadow. And the machine with 98% confidence would say it's the same guy. I didn't know it's Armen because I didn't type Armen on yet, but with a high confidence, it's the same guy. 10 years later, we didn't need 50 pictures. 10 of them, 10 pictures of me. At 98%, it said it's the same guy. We're not there yet, but I would like to see just one or two pictures of me submitted to the machine, just normal, one here, maybe one like that. No need to do any sort of actions. And I want the machine to come up and say with 98%, that's the same guy. That's hard. It's really hard. Maximum AI with minimum data. Working towards that. All right, my friends, we did great. And let me see if I have missed anything over here. I found one other nice tidbit that I can entice you with. On pages 43 and 44, they talk about overfitting, sample size, outliers, missing values. Oh gosh, these are nothing to scoff at. They certainly are considerations and concerns to be had. I'm going to tell you a quick story, then we'll call it a wraps. We'll start off on the next chapter next time. This goes back to pre-COVID days. And early in my career as a data scientist in the Watson team, they sent me to Singapore. Gosh darn it. Citibank. Citibank in Singapore, I believe it was there. So as a consultant, I went in and they wanted to see how they can infuse AI in some of their work because fraud was starting to take a foothold in a big way. We wanted to do fraud prediction. Now, they had two types of data, they were telling us. We have transactional data, they told us. That's in a CSV file. Our tellers, what time they come in, what they work, where their address is, and what time it's open, things that you can put in a table in columns and rows, transactional data. And then we have other sorts of data. Because what happens is that anomalies are caught by the machine. John, who's been going to Alice, a teller, for the past few years and depositing his $5,000 check every month, some such. All of a sudden, is going to Alice, or more interestingly, has decided not to go to Alice, but it goes to another teller. That teller is actually a friend of John's, and is now depositing 15,000. What is this? Did they get a raise or something? Maybe. But this is an anomaly, something that the machine picked up. So I'm curious, what is going on? Theft and fraud can happen in various levels. There's at the teller level, and then there is at the C level, upstairs. And come to find out, the machine has a sense of, the machine does NLP, natural language processing. Their emails is owned by Citibank. He's looking at their emails and starting to see a sense, find out that there's a conversation going on about money laundering in here. That's what those deposits are. So there's a collusion between the teller and the customer, something that they're doing in secrecy and so forth. I want to find that out. So now I got to go to unstructured data. So the notion of outliers is essential in here. And then there's the notion of missing values in A, or the cell is empty. Well, as a data scientist, we have to decide, do I delete that or do I keep it, their entire row? This outlier notion, the overfitting notion is also a bit of a nuance in here. Let's say we have a town, and the school that I go to, that I'm teaching, WIT, Wentworth Institute of Technology here in Boston, Tuesday nights. So let's say we want to find out what GPA gets students accepted in WIT. So the students that have come in, we ask them, we check and see 3.1, 3.2, 3. Let's say about 3.2, 3.3 is the acceptance rate of the students that come in. So we learned it. The machine found the pattern. We get those who get a GPA of 3.2, 3.3. I'm making it up. Actually, it's lower than that. And All of a sudden, we decide to make a prediction. So we ask the same people about their GPAs, and the machine does really good. And we're like, wow, what an amazing thing. So when the new people come in and we ask them, it's all of a sudden the answers are totally off. And let me give you another example. Let's say the professor says, folks, we have chapter 1 and 2, study those. We have an exam on next week, next Thursday. Fine. So students are you're studying these. There's some questions at the back of the chapter, and the answers are in the appendix. Supervised learning. You're trying to answer the question on your own. You're like, I don't think I got that right. You look at the index there, there's the answer. You're like, okay, I got it. We call that learning. The answers are given. So you go to the exam, the test, and you're looking down, and it's the same darn questions. You're like, wow, what's wrong with this professor? Is he soft in the head? Because everyone's going to get an A. So the professor, you have a test set, a training set is what the students were involved in, and then you have a test set. It's different. Now the professor knows the answers to those, of course, it's got this cheat sheet and so forth. But how ridiculous is it to give you the same exact questions for the exam that were actually at the end of the chapter? That's overfitting. Say no to that. All right, my dears, we've done great. We shall see each other on the next round.